Suppose we want to evaluate this expression. It says 3 plus 4 times 2. Well, one person evaluating the expression might think, well, let's see, it says 3 plus 4, gee, that's 7. So maybe this is 7 times 2, or 14. And someone else might say, well, I see multiplication here, so why don't we multiply first? Another way to do it maybe is 3 plus, let's see, 4 times 2 would be 8. So 3 plus 8 would give us 11. These are different answers. One of these must be right and the other is wrong, but which one? Well, it turns out that because of situations like this, where we have a choice in performing two different kinds of operations, that we agree on some method of approaching this kind of problem. And we have what's called an order of operations agreement. You see, if it were the case that it were intended that we would add the 3 and the 4, we can give a guideline for that operation like this. We can actually add parenthesis into a problem, and the parenthesis means do this first. And so if we were adding 3 and 4 first, we would indeed get 14 when we evaluate the expression. But otherwise, we get the 11 as we found here. This would be the more correct way to do it without the parenthesis. At any rate, we have this order of operations agreement. We simply agree on sort of a priority in performing arithmetic operations in expressions like this. And the agreement is this. We start with parenthesis or other symbols of inclusion. There are 3 types. This is parenthesis, brackets, and braces. They all mean the same thing, and they mean do this first, and they could also mean multiplication. We'll get to that in a minute. I'll show you those situations. But the reason we have 3 sets of them is because sometimes they are nested within one another. So it's possible that we would have to use more than one in a particular problem. Well, at any rate, it says, these say do this first. Do this first in the problem, and then look outside of the symbol of inclusion to see what else is left to do. Well, the next thing we do, the next priority is to take care of exponents that appear in the expression, and after that we perform any indicated multiplication or division from left to right. Now, the multiplication and division don't take precedence over one another. It's whichever one occurs first from left to right in the expression. And then after that, we take care of addition and subtraction. So using this order of operations, you see, no wonder in this problem. Now let me go back to the original. See, it was 3 plus 4 times 2 like this. We have no parenthesis, so we skip that part of the order of operations agreement. We have no exponents, we skip that part of the agreement. The next idea in the agreement is multiplications or divisions from left to right. Well, from left to right, we have this multiplication. You see, that's why we multiply 4 times 2 first to get 3 plus 8 and then 11 for the value of the expression. All right, let's practice this a little bit with a few problems. Here we have a parenthesis involved, and the parenthesis says, do me first. And so we look inside the parenthesis, ignore everything else. The tendency here for students is to add the 3 and 2 because they come first in the problem, left to right. And the tendency then is to put a 5 here to the left of the parenthesis. But do we want to do that? No, we want to work inside the parenthesis and bring down everything else. So we bring down the 3, the plus, the 2, and working only inside the parenthesis, 7 minus 1 is 6. Now I can write the 2 times 6 like this, or I could write it like this, and it would be okay. These are kind of interchangeable ways to write it. But either way, it indicates multiplication, and either way, according to our order of operations agreement, the next thing we need to do is multiply from left to right. The 2 times 6 is 12, so we would get 3 plus 12, or 15 for the answer. In this next one, very similar idea, almost identical to this other problem, but I want to emphasize here that we don't take 2 from 12 as the first order of business. This is just bait out here, testing to see if you know to ignore this and to work only inside the parenthesis. So you look in here first and you perform that operation. So bring down everything else and work within the parenthesis, 3 plus 1, 4. And now multiplications from left to right, here we go. See, there's no exponent, so we skip that part of the agreement. So it's 12, then minus 2 times 4 is 8, 12 minus 8, 4. In this one, we have an exponent. No parenthesis here, though. So we skip the parenthesis idea, but the next notion in the order of operations agreement is to take care of the exponents. And we're squaring the 3, so we have 4 plus 3 squared would be 3 times 3 or 9, and then 4 and 9, 13. Now notice we're not adding the 4 and the 3, 7, and then squaring 7. And that's wrong because 4 is not part of this, the base of this exponent. Certainly we're not going to make it a part of the base of that exponent. Okay. In this one we have parentheses. Now notice the similarity between these two. We have 4 plus 3 and we have squared. We have 4 plus 3 and we also have squared. But we have a parenthesis in here, and it changes the dynamic of the problem altogether. This says to work in the parenthesis first. So we do collect the 4 and the 3, you see, to get 7. Now I can keep the parenthesis or not keep it. If there's only one term within the parenthesis, it means the same thing whether you keep the parenthesis or not. 7 squared written like this and 7 squared written like this mean exactly the same thing. Either way you cook it, we're going to get 49. Now, here's one that's quite a bit more complicated. On this one and the next one, you might want to have a look at the problem and write it down on a piece of paper and try it on your own, and stop the tape when you do that, and then roll the tape to see if you have a correct solution. But here's how it goes. The order of operations agreement says work within parenthesis or other symbols of inclusion first. We see a parenthesis here, so we perform this operation first. And we bring down everything else in the problem. And it's important to discipline yourself to do that. It's 2 times. Now working in here, we get 5. Minus 2 cubed. And the tendency is to think, well, can we do anything else now? Can we do anything else in the same step? Well, mathematically, it turns out that there are situations where we can perform more than one operation. But the safest thing to do is to perform only one operation per step. That's the safe thing to do. And to wait until you gain quite a bit of experience before you start to try to perform more than one operation in a single step. All right, so here we go. The agreement said that we work within parentheses. We've accomplished that task. The next idea is to work with exponents, and here we have an exponent on the base 2. So it's 2 cubed or 3 factors of 2, and that's what we'll do next, bringing down everything else. Now it would be okay to change this 2 times 5 to 2 times 5 like this. That's perfectly all right. But here we have 2 cubed is 8, and then plus 6 divided by 2. Now, we've finished with symbols of inclusion. We've finished with exponents. The next item in the order of operations is multiplication and division, whichever comes first, from left to right. So from left to right, 2 times 5, 10. Again, multiplication and division from left to right. 10 minus 8, that's not multiplication or division. Plus, that's addition. Oh, here's division. All right, let's perform this, this task. It's 6 divided by 2. That would be 3. So we have 10 minus 8 plus 3. You see, we're only doing that, so we get the 3. And now addition and subtraction from left to right. 10 minus 8 is 2. 2 plus 3, 5. Notice only one operation in each step. Now, we probably understand that right here we could have performed both of these operations in this step. After all, 10 minus 8 is 2. We imagine the 2 plus 3 gives us 5. So we could have done all of this maybe in one step. But right now, the safe thing to do is one operation per step. Here's another one. And this is another one that you may want to copy down, stop the tape, and try it on your own, and then roll the tape. All right, let's go through it. We're looking for, let's see, the first priority in the order of operations agreement is parenthesis. And we see the parenthesis way over here. So our attention goes right into this parenthesis, and we're looking inside here. Everything else is just background noise as far as we're concerned. All we're going to do is bring down all that business. So let's do that. We have 30 divided by 10 times 2 cubed plus 3. Now that's everything outside the parenthesis. We're working inside. 6 minus 2 is 4, so we do that. All right. The next order of business would be exponentiation, dealing with the exponents. We have one exponent here, So all we do, and our attention is just right in here. Just right in here. Everything else is just going to be brought down. So we have 30 divided by 10, and now we do this. 2 cubed is 3 factors of 2. 2 times 2 times 2, that's 8. So we have times 8, and bring this other business down just as we see it. All right, and away we go. The next order of business after the parenthesis, after the exponentiation, is multiplication and division from left to right. Now you might say, well, we have parenthesis over here. Yeah, that's true. The parenthesis here indicates multiplication. We have nothing to do inside the parenthesis. The emphasis in the order of operations agreement when we talk about symbols of inclusion is to work inside, to see if there's some activity or some operation that we can perform inside. And then we treat it as though it were just another multiplication symbol, because it is. All right, let's see. From left to right, multiplication and division. Oh, bam, we encounter one right here. 30 divided by 10 is 3. And I'll just bring down everything else just the way I see it. Now, I could use a dot here, and that would be okay. All right, from left to right, multiplication. 3 times 8, 24. I could use the dot here again. Left to right, the multiplication rather than the addition here. So we have 24, and my attention is here. 3 times 4, 12. And then collecting 24 with 12, 36 is the answer.